Now we will discuss how to analyze the time complexity for external sorting. Time complexity for external sorting. Okay, here if you want to perform external sorting, you have to read the information, that is the records from the disk, and write the records into the disk. That means you have to know the read or write time. Mainly we have three factors. That influence the read and write time. That means three factors that influence the time complexity. So what are the three factors? The three factors are seek time, latency time, transmission time. Okay, what do you mean by this one? Generally our disk contains different number of sectors, cylinders, tracks, and so on. Seek time means, suppose we are reading information or writing a record. We are reading record from a particular position or writing record into a particular position. From which position we have to read or to which position we have to write? Simply to position the record. Seek time is simply to position the read or write head. To position, that is on which position you have to perform read or write operation. Read or write head on the required cylinder. This is called seek time. Okay, generally the seek time depends on the number of cylinders contained by the disk. Okay, simply remember this one. To which position we have to perform read or write operation. Latency time. What is the latency time? Simply it is the time taken to position the head onto the right sector on the disk. Okay, here in the seek time to position the read or write head onto the required cylinder, but in the latency time it is the time taken to position the corresponding head onto the right sector on the disk. Okay, the first one is depends on the cylinder, and the second one, latency time, comes under sector. Simply transmission time, the name itself specifies. What is the transition time? The transition time is simply the time taken to transmit a block of data into the disk, that is to or from the disk. The time taken to read a block of data to or from the disk is called transmission time. These are the three times that affects the time complexity. Now for implementing the time complexity, I am using some notations. So what are the notations? TS. Suppose remember these notations. By using these notations we can derive the formula. TS is the maximum seek time. What do you mean by term maximum? That is, this is the maximum seek time for that particular algorithm. TS. TL, the maximum latency time. So for transmission time, TRW. So some of the notations prescribed in the book. TRW means simply transmission, that is the time to read or write one block of records. This is a TRW. Now use some more notations. TIO. IO means input output. Simply what is the meaning of this one? Time to input or output one block. Now what is this answer? TIO is obviously the identification in the cylinder and that identification in the sector, and then perform read operation. That is sum of all three times comes under TIO. That means TIO is simply TS plus TL plus TRW. Okay, time for input and output, that is time to read one block of data, TIS. So what is this one? Internal sorting, time taken to internally sort the records, in which position? In memory. To internally sort the records, that is, in the first step I am reading a block of data and perform sort operation. So for reading TIO, to perform sort operation TIS, then what is the next notation? After sorting we have to perform merge operation. So N into TM. Here what is the meaning of this one? To merge time taken to merge n records from the input buffer into the output buffer. So to merge n records, the time required is NTM. Okay, remember these are the notations. Now based on these notations, consider an example and analyze the time complexity. Now consider this example to analyze the time complexity. Assume we have a list that consists of 6,000 records. And these 6,000 records is to be sorted. By using an internal memory that capable of sorting at most 500 records. That is, internal memory can sort at most 500 records, and the input, that is the list 6,000 records, are stored in the disk in blocks, and the size of block is 100 records. This is the given question. 6,000 records, the internal memory, and the size of each block. Now you have to perform the operation. So what is the first step? We have total 6,000 records and the size of each block is 100. Then how many number of blocks? 6,000 by 100, 60. So the first step is read 60 blocks. To perform sort operation, read 60 blocks of record. So for that we are using the notation 60 TIO. That is, I am reading 60 blocks. After reading 60 blocks, what you have to perform? You have to perform sort operation. And the sort operation is performed in the internal memory. The size of the internal memory is 500. So 6,000 by 500, that is 12. So for sorting operation, it required only 12 parts. You got it? This is for reading a block. This is, we have total 12 parts. That is, 6,000 is divided into 500. That is, first to 500 records are placed into the internal memory. Perform sort operation. Next to 500, next to 500, next to 500. That is, each and every time we are reading 5 blocks. So assume this is the internal memory. This internal memory has 1, 2, 3, 4, 5 blocks. At a time I am reading 5 blocks into the internal memory. After sorting, what you have to do? Again write the blocks into the disk. So again 60 IO. Now what is the total? The total is 120. 60 plus 60, 120 TIO plus 12 into TIS. This is the time for step 1. That means after completion of step 1, what happens? Different runs are generated. How many runs? We have 12. That means we have 12 runs are generated. Now come to step 2. What is the step 2? Step 2 is simply merge the runs. If you are using two-way merge sort, assume if you are using two-way merge sort, so merge the runs 1 to 12 of 500 records each. 500 records each, that means run 1, run 2, run 3 and so on, run 12. These are the 12 runs. Merge these two, merge these two, merge these two and merge these two. So in this process we have to perform merge operation. So to perform merge operation, how many records we are merging? We are merging in either a two-way merge or three-way merge. In this step I am scanning, that is I perform merge operation for all the 6000 records. For all 6000 records. Now first I am reading this one, this one, this one, this one, this. So total what is the time? I am reading the total information, that is the total records, and again place the total records, and after reading I am performing merge operation. Observe carefully here. I am reading and writing 6000 records. The time is this one. For internal sorting the time is this one. Here for reading and writing this one. For I am merging 6000. How many number of records you have scanned? I have scanned all the 6000 records. Now step 3. Now how many number of runs we have? We have runs from 1 to 6. That is, now we have only 6 runs. The size of each run is 1000 record. The size of each run is 1000 records. That means in this step this happens. That is 12 are converted into 6. Again what is the time? In this case also I am using all the 6. That is I am reading the total one plus perform merge operation on the total one. Now by performing this one, this happens. That is the 6 are converted into 3, each of size 2000, each of type 2000. Now step 4, merge. Here this is a two-way merge. We can merge only 2 runs. We can merge only 2 runs. That is, suppose I am merging only these 2. That means I am reading only these information and writing only that information. You got my point? So that is the reason step by step I am representing in a diagrammatical format. So 12. I am reading total 12. I am reading total 6. I am reading total 3. But in this case I am merging only 2. That means how many number of records you have to do? 4. That is 2000 plus 2000. You have to read only 4000 records. Read 4000 records. That means 40 blocks. That means the 40 blocks of data, and again we are writing 40 blocks of data. 40 plus 40, 80 block of data. And I perform merge operation only 4000. Finally in step 5, now I have to merge one 4000 and one 2000. Merge the runs. One size is 4000, one size is 2000. That means I have to read all 6000 records. I have to read all 6000 records. That is 120 T10. Perform merge operation. This is the total. That is the finally we are getting a single run of all sorted records. Now sum all these terms. By summing all these terms, this is the time. This is the time required for implementing. The time required for implementing, that is for sorting external, for performing external sorting. Performing external sorting. Suppose for your convenience I will discuss one more example. This example is also considered. We have 4500 records. How to solve? And the internal memory. Suppose internal memory can sort 750 records. The size of block length is 250 records. Remember the procedure is same. Depending on the value we have to modify. So what is step 1? Now how many number of blocks we have? Total 4500 and size of each block is 250. So the number of blocks are, so how many number of blocks? 4500 by 250. That means 4500 by 250, 9 blocks. So we have a total of 9 blocks, right? We have total of 9 blocks. Observe. Okay. Now 250 25 by, okay. Now divide how many number of blocks? We have to read 9 blocks. We have to read 9 blocks, and that means reading 9 blocks it takes 9 TIO. Reading 9 blocks it takes 9 TIO, and again perform sort operation. So how many number? So we have to perform sort operation for 750 records. Here I am performing 500 records, so 6000 by 500, so 12 into TIS. Now 4500 by 750. So what is the value? That is 18. So 4500 by 750. What is the value? 0. So 5 ones are 5 fifths, 6. Okay, total 6 internal memory, total 6. So what is the time? 6 IS plus for output also again TIO. Though simply what is answer? 18 TIO plus 6 IS. So please ignore the calculation part. Simply block size is 250. So how many number of blocks you have to read? 4500 by 250 block. That means suppose I am getting 9 blocks you have to read, and how many number of sortings? That is internal memory can store 750 records. So 4500 by 750, that is 6 internal memory. Again you have to perform write operation. Now step 2. How many merges we have to perform? How many merges? We have total 6 values. Now run one. Suppose assume 3, 4, 5, 6. In the first step we have to merge this one. Suppose each run of size 750. That means I am reading and writing all the blocks. I am performing read and operation of all the blocks, and 4500 TIS, 4500 TM, and that means I am merging all the 4500 records. Now in step 3 I have only 3 runs. The size of each run is 1500. In this case what I am doing? I am perform merge operation between only 2 blocks. That means see here total 9 blocks. Now I am reading only this one. That means only 6 blocks. Reading 6 blocks, writing. That means a total of 12 TIO, and perform merge operation only this one, 3000 TM. And finally in step 4 I have 2 runs. One is of 3000, another one is of the size 1500. Totally I have to perform all the read and write operations. So finally what is the sum? 18 plus 18 36, 54 66 TIO plus 4000, 4500, 900, sorry 9000, 12,000 tm, 12,000 tm plus 6 is, 6 internal sorting. This is the total time for this example. Remember, whatever the example given, simply divide in this manner. So in the next we will discuss buffer handling for parallel operation.